Hello, everyone, and welcome to today's Embase webinar. I am the Product and Marketing Manager for Embase, Xuanyan, and I will be your host today. Before we get started, I would first like to check if the channel is working. Can everybody hear us? So if you could type in some feedbacks on the feedback form, such as "we can hear you" and "we are ready to go," just to give me a signal that we are ensured the channel is working properly. And meanwhile, I would like to also make you aware that this webinar will be recorded, and the recording will be immediately available within the same link. The presentation slides will also be made available for download afterwards. Okay. If you would like to get in touch with us to talk about your needs for Embase or Mendeley, please refer also to the link that we provided in this webinar channel. And there are also lots of other interesting content available on the Bright Talk Life Science channel, such as pharmacovigilance subject, reaccess for chemists. Please also check out more videos and live sessions. And we would like to hear also your opinion about the webinars and what other subjects you would like to follow. All right, I am not only alone today. Today in this studio, I also have Max Dumoulin, the Vice President Product Manager at Embase, at Elsevier, as a co-speaker. So Max is an experienced manager in the research information industry with previous function in product development, marketing, communications, and sales. Next to Mendeley Institutional Edition, he is developing products that supports the purchasing function within the research-intensive institutions by providing analytical insights about value and utility of online research tools. His approach can be described as knowledgeable, enthusiastic, and driven by curiosities with an aim to improve all aspects of the customer experience. Max holds a Master of Business Administration from the Erasmus University Rotterdam and a Bachelor of Art in Philosophy from the University of Amsterdam. So Max, you're on the line. Would you like just to say hi to the audience at first?
Yes, thank you very much, Sean. Hello, everybody. Welcome, and thank you for joining today. I hope you'll stay till the end, because then I'll do a little bit of demoing of how to do a systematic review using Embase and Mendeley. So I hope you're looking forward to that as much as I am. Thank you very much.
Thank you, Max. Max, I'm certainly looking forward to your part as well. Today, Max and I will work together. We will talk about the systematic reviews in Embase and how to conduct it also in the Mendeley. The objective of the talk today is to support academic research and evidence-based practices. Right now, we do not have a formal Mendeley offerings for the corporate customers. So for the corporate customers who are interested in the reference management and literature management tool, please contact us directly. Our specialized life science consultants can then provide you more customized offering based on your needs. So let's get started with today's webinar. This webinar will be split into two parts, as I said before. First, I will start with the basics of the evidence-based medicine and systematic reviews. And after that, I will go on to talk about the concepts that forms a PICO search strategy and how to use a PICO form in the Embase. Then I will give the floor to Max. He will talk about how to search in Embase and then demonstrate how to conduct a review with a group in the Mendeley. So to start off, I always want to start with the definition of the evidence-based medicine. If you're already familiar with it, and then please bear with me, we're going to go through the concept and the principle very quickly. Let's imagine that you are a doctor, and then you have just diagnosed your patient with the stage 2 prostate cancer. This patient is 57 years old and not showing any symptoms. Naturally, being a doctor, you would like to provide your patient with the best treatment and with the optimal outcome possible. What actions and course of treatment you will choose relies largely on the practices of the evidence-based medicine. So evidence-based medicine, also short for EBM, combines the systematic search for the best relevant evidence, the expertise of the clinicians in the relevant fields, and the patient's value and the preferences. The objective is to provide the best possible treatment for this patient. And there are lots of different branches of definitions and the principles of EBM, but in general, 5 major steps are defined for the practices of evidence-based medicine. First step is to ask the question, expressing the problem as a clinical question. Second is to acquire the evidence. That means finding the evidence-based resources that can answer such clinical question. Third is to critically appraise the evidence and make an assessment. And then fourth is applying the evidence. Last but not least is to re-evaluate evidence and make necessary adjustment of its application. Apparently, every step is important, but today we're going to focus on the step 2, acquiring the evidence. The key question here is, what makes a good evidence, and where to find the best available evidence, and how to find them as comprehensive as possible. Before that, we really need to first understand the level of the evidence and what makes a good evidence. Talking about good evidence, then I have to talk about also the pyramid, evidence pyramid. So this pyramid right now illustrates the different type of study design according to their increasing quality and the reliability of the evidence. At the bottom of the pyramid, you will find that the first level of the evidence is the background information. And level up is the first stage of testing and observation, for instance, case series, case control studies. And then going up in the middle, you will find the randomized control trials. And then on the top of the pyramid is the highest quality of the evidence, the systematic reviews. Systematic review uses advanced, defined, and transparent procedures to find, evaluate, synthesize, and appraise the results of the relevant research. This practice is really designed to minimize the bias as much as possible. Nowadays, there are many organizations that are involved in producing systematic reviews, providing guidelines, and also giving the training on conducting systematic review. The most common ones are the Cochrane and the Joanna Bridget Institute. And other well-known organizations include the Center for Review and Dissemination at the University of York, as well as the Campbell Collaborations, which is promoting the social and economic changes through the evidence-based policy. Now, recognizing the evidence-based decision brings a stronger impact. There is also an increasing focus on the production and the dissemination of systematic reviews. In the Embase, you can see searching systematic review in an explosion way and break down the records by the publication year. It's very clear that the publication rate is going exponential. And meanwhile, increasing published systematic review is referencing Embase as one of the searching tools to identify the evidence. Beyond the systematic review, evidence-based medicine has also very broad application and impact in the healthcare industry. You will hear more and more often about its wider applications, such as providing the evidence-based clinical practice guideline, health technology assessment, and recently, European Commission also published a guidance on the clinical evaluation of medical devices, so-called MedDev 2.7.1, requiring that device manufacturer to systematically assess and analyze the clinical data for creating medical device clinical evaluation reports. So what does a systematic review include? Now let's look at an example. This is a Cochrane review and published on 2017, February 4th. So this title of the systematic review is Topical Anesthesia for Needle-Related Pain in a Newborn Infant. The review itself evaluated the efficacy, the safety of the topical anesthetics in the newborn terms or preterm infants. The table of the content that is listed here also cover, for instance, abstract, the plain language, and the methods, and some findings, the background, objectives, also additional summary of the findings, discussions, and also the author's conclusions. You can see all the Cochrane systematic review follow more or less the same format and the methods, and this really ensures the transparency and the rigors. So now we know what does a systematic review contain. So how is this actually made? It usually follows this general 8 steps that is showing in this illustrate. And today we are going to talk about the first and the third step, how to identify the issue and how to search for the studies. As with many research, the first and the most important step is actually to determine its focus. So clearly framed questions help to determine the structure of a systematic review. It will also guide the strategies for locating, selecting the data, the studies, the evidence, and assessing their relevance and the validity of the subject. And Cochrane Handbook for Systematic Review of Intervention has a very clear guidance on how to review those questions and how to develop the criteria for including and excluding studies. So I'm showing you the chapter 5 of this handbook, and keep in mind that we are looking at the version 5.0.1, and I know that Cochrane is actually planning to release the version 6 this year, and there will be major updates in some part of the chapters. So I would recommend you to go to the Cochrane page, which I have showing you the link at the bottom of the page, and to check what has been updated in the new version. But back to this, so the general methods for the review has been pretty much defined. In the current version, Cochrane highlighted that a clear, defined, focused review begins with a well-framed question. So there is no doubt. And review questions should specify the type of the population, the type of the intervention, and the type of the outcomes that are of interest. So the acronym PICO is recommended to use to set up the framework for such question. So here the PICO stands for participants or population, for intervention, for comparison, and for the outcomes. In the next few slides, we will look at the PICO acronyms in greater detail. So let's start with P. P can be population, can also be patient. For instance, you can ask the question about the age of the population, the gender of the population, and you can also ask about problem. For instance, what's the disease, and what's the severity, and what's the stage of the disease. All those can be defined as P element in the framework. And next is the I for intervention. Here refers to what's the treatment. It could be, for instance, the drug dosage. It can also be duration, routine of the administration, etc. C stands for comparison or control. That asks the questions, what other treatments could be used? And it can also be alternative treatment, can also be a placebo, or can just be left as a blank. And then the last one is O for outcome. What is the desired outcome should be the element for search to fill in this framework. It can be, for instance, reduced risk. It can also be reduced mortality, increased mobility, or improve the quality of the life, etc. So these 4 different elements then form the PICO framework. And when all the 4 elements intersect together, the overlapping area then represents the evidence that is addressed by the questions we are asking. Often people also apply an additional filter, the study type. This can combine, for instance, with the randomized control trial, clinical trial, or systematic review or meta-analysis to further narrow down the search results into one type of very specific studies. In the following slides, I think I want to show you a few examples of how to slice such clinical questions using the PICO framework that we have just explained. So let's start with question 1. In this question, we are asking what are the best empirical antibiotic treatment options for the bacterial meningitis. So population refers to, for instance, patient, the disease. So here we could define the population as patients with bacterial meningitis. Intervention means what kind of treatment are given, and here we are looking at antibiotic agent or the antibiotic treatment. Comparison is not mentioned in this question, and neither is the outcome. So it is possible sometimes we just fill in the population and the intervention elements, and we do not have any specifically defined comparison and outcome. But such two elements has already clearly defined the clinical questions that we are asking, with the most important elements, population and intervention. Next question. In patients with prostate cancer, does androgen deprivation therapy reduce the recurrence rate compared to no treatment? So here the patient or the population is defined, the patients with prostate cancer. Intervention here refers to the androgen deprivation therapy. And comparison, because the question clearly said no treatment, so we can fill in no treatment, we can also leave it as a blank. Outcome is the reduction in the recurrence rate of prostate cancer. So when you are considering or when you are defining the outcome, it is always advisable to make it as measurable as possible. For instance, a study is better to have a statistically significant findings. And ideally, the outcome we are looking at, especially for reviewing a clinical questions, most often we are looking at the measurement of the quality of life of the patient. And the third question, which is going to be the last example we are looking at, does the application of a topical anesthetic applied on the skin reduce the pain in newborn infants who require a procedure that punctures the skin? If you still remember the example we showed before, this actually refers to the systematic review example we have just seen that was published in 2017. So this question is literally taken out of that systematic review. So in that question, we can define the population are the newborn term or preterm infants who require the procedure involving puncture of the skin and other tissues with a needle. And intervention or the treatment to those infants refers to a topical anesthetic application. So this can be eutectic mixture of local anesthetics or methacin, or even simply topical anesthetic. Comparison, we are not comparing with anything at this moment, so we can leave it as no treatment, placebo, or simply blank. And outcome, we want to find all the evidence that is referring to reduce the pain. So this is also an example, or this is also the defined elements in that systematic review that is published in the Cochrane databases. So here what we can actually also learn that when you are looking for the PICO information, or when you're trying to slice a PICO question into different 4 elements, it is always advisable to search for similar questions or similar clinical assessment has been done in other systematic reviews. That can give you a guidance and an idea how to slice and how to actually define the elements just to be comprehensive as possible. So now we have identified a question, and then we have also used the PICO framework to slice the question. Next, we need to translate it into effective searches to find the best and the most relevant evidence. And this steps then requires, first of all, some knowledge of medical informatics, and then also know-how of searching and where to search for. Similarly, in the Cochrane Handbook, Chapter 6, there is a very well-defined guidance on how to conduct a search for the studies. The handbook first acknowledged that the trial registers and the trial results registers are very important and important sources for the information. And also the handbook recommends to search Central, to search Medline and Embase for different reports and the trials. And thirdly, applying the information search techniques such as using free text, subject heading, or preferred terms are recommended, also highlighted, guided in this handbook, how and where you can do it. On the next few slides, we will look at the third example of this local anesthetics application in the newborn infants, and to make use of some search tools that is available in embase.com to find those answers. To first start with some general search strategy of building a search query in Embase is that we always recommend people to start with Mtree to identify the most preferred terms. For some of you who are not familiar with Mtree, I recommend you to listen to the webinar that was conducted last month. We went through thoroughly about Mtree in Embase. But in a nutshell, Mtree is a controlled vocabulary for describing the biomedicine and life science concepts. It includes a whole range of terms for drugs, disease, medical devices, and other life science concepts. They are also organized in the tree structure with stem, with main branch, and also with narrow branch. For instance, you can see it here. For the purpose of the consistent indexing and the searching, a group of equivalent terms are usually generally treated as having the same meaning, and as such, one single preferred term is used to represent the rest terms in this group. It is important also to take into account both preferred terms and non-preferred terms when you are developing some sensitive search strategies. So that can be also a synonym, similar terms, trade names, or a lab code name to a preferred term. So it is always good to consider and include them in the search query so you can be comprehensive. And we always recommend our users to start searching in the Mtree first to identify the preferred term. For instance, you can see the newborn infant in the Mtree here. This is first mapped to the newborn. So it is first when I search newborn infant in the Mtree, it will actually give me a recommendation what is the preferred term in the Embase. So this is first mapped to newborn. And then you can also find out what are the other descriptions of the newborn. For instance, child newborn in a different order with a comma, or full-term infant that is also used to describe the newborn, etc. Once we found all those preferred terms, and then we found all those synonyms, we take, for instance, we take some notes on the synonyms. And then we want to include all those synonyms in the search queries. For instance, in the previous example, we want to search for the newborn infant. So the patient here, we would start first with a preferred term search in newborn. And we also want to include other terms that is searched in the title and abstract. So this search query would give you a more comprehensive results rather than just searching newborn itself. And next, so we want to translate the whole search query or whole clinical questions into a PICO search form. So the left side is what we have discussed. What are the elements are defined or referred for each element of the PICO. And then the right part of the table, you will see what are the actual search terms or actual keywords that you need to search in the Embase. And then in the end, 4 different elements are automatically combined using the AND Boolean operators. In the Embase, we have developed a few tools to help you to make such query building easy and fast. First and foremost is the PICO search form. This was introduced in 2016, and this form clearly separates the clinical question into those 4 elements, as you can see: population, intervention, comparison, outcome, and additional option for adding the study designs. And between each element, they are automatically connected with AND Boolean operator. And within the element, the system will recognize them and using OR Boolean operator automatically. Another advantage of this form is on the left side, we introduced entry and also a list of the synonyms, which I will show you in the next slides. So the example of this newborn infant with local anesthetics. We start with searching newborn, and once we found the newborn, and system will automatically find the 15 synonyms that is associated with this preferred term. And this will show you on the left side of the table. You can go through the list of the synonym to exclude the ones that you do not want to search. For instance, the neonatal animal in this list of the synonym is not the one we are searching, so we can just close this, and the rest will be all searched in the title in all the records area. And next is the intervention. So we just simply need to add, for instance, the eutectic, local anesthesia, and also the topical anesthesia. Similarly, the synonyms will be also automatically added, and then followed by comparison and outcome. Within the element, you can see they are connected with OR, and between the elements, they are connected with AND connector. And the form automatically calculates the search results and displays it in real time. In the results page, you will also see a detailed search query that using the search form we have built, and you will also see the list of the results and the list of the records. The search terms that are used in the query will be highlighted directly, so just for a direct and straightforward review. You can also review the records directly on the results page by clicking abstracts or clicking the index terms. What you can also do is to click the title of the record and go to record page straightforward, and then to review more details such as bibliographic information, index terms, and also the triple linking information. They are all provided on the record detail page. Second tool I want to talk about, in addition to the PICO search form, is the index miner. Index miner was introduced last year in July, and you will find the index miner icon on the results page. The main goal of developing this search tool is to actually allow you to add more comprehensive search strategy, but save some time. So what Embase does is to scan through the results of your search and rank all the index terms that appeared in the records of your search results. Often you will see common index terms such as human, child, but going through the list, if we go to page 4, page 5, you will see more interesting and specific terms that actually you want to add into the query. Simply select them and then use or select the correct Boolean operator and then add it to the query directly. And then we have another new tool that is developed last year that's called the similar records. So this can be found also on the records page and next to the individual record. What the system does is to display the first 100 records similar to this record. The search is then executed as a combination of the major search term, major focus term that are used to tag this record. Then results sorted by the relevance and limited to only 100 records. So the top 100 that you will see. This is also an additional search tool for you to find interesting records starting from only one record or only one article that you're interested in, and help you to expound more different search terms. And Embase can also provide many different options to manage the results once you have identified the query, once you have finalized, and then think that is the evidence, that's the list of the records you're looking at. You can, of course, share and export the records. I'm sure that Max will show you some key features in Embase and how they can be actually seamlessly integrated with Mendeley. But before that, I just want to highlight that this year we have been actually working to improve the export functionality in Embase. In addition to the RIS format for Mendeley, for EndNote, we have also added some new formats that can be also exported, for instance, XML, Word document, and Excel documents. In addition to share and export function, you can also save the records to the clipboard. You can also save and share the search query itself with your systematic review coworkers. And you can also set up the email alerts to receive notifications when the new records are published that you want to receive the notification. And this concludes my part of introducing you to the Embase and the searching for systematic review in Embase. And next, I'm gonna give the floor to Max and let Max to show you how to do the systematic searching in Embase and also how to conduct it collectively and collaboratively with your colleagues in Mendeley. So with that, I give the floor to Max.
Hi, Siobhan. Thank you very much. Thank you, everybody, for being on this very important topical webinar in such great numbers. It's great. Thank you very much. While I try to share my screen, I'm not very good at multitasking, of course, as you can imagine. So I'm just focusing on that for just a few seconds. Yes, I think I'm here. So thank you very much for joining in such great numbers this important webinar. I would like to show you very, very briefly how you could potentially do a systematic review in Mendeley using Embase. So before I do that, I'll quickly show you what Mendeley is. This is Mendeley. This is the feed, one of the features of Mendeley. So Mendeley, as you probably know, is a reference and document manager. The advantages of Mendeley are that it's available on any platform, so Windows, Apple, anywhere, mobile. Also that it's got a desktop version, so you can use it on your locally anywhere. And an important aspect of this also that it's free, so you can just create an account and start using it. And it also has got other functions, for example, funding opportunities, as you can see here. Yes, so here we are searching for, and as you can see, there's 21,000 opportunities. One other thing that's also very popular with researchers is that there's a profile, but also a stats page, and this shows researchers where, how the records that have been published before by them are actually being viewed and cited, etc., and also we show some other metrics on this. So this is all kinds of other things that Mendeley does. So what I would like to show you today is how to do a systematic review. And of course, systematic reviews can be done by a single person, but are usually done, as Siobhan explained, in a group. And this is also nice about Mendeley, because Mendeley is not just a document manager for individuals, but it's also collaboratively working. So you can add groups. So the free version has got the option to create groups with up to 25 people. So that should normally be enough for a systematic review collaboration. So in my groups, I would create a group, and I would call it group on Wednesday, for example. Well, it doesn't really matter because I've created a group somewhere else, so I'll do that. I can describe it, I can choose a discipline, but it's also very important. This is something that I don't want to share with everyone, so it's a private group, and I can create it. And what I then can do, I can actually invite members of my team to this group. Okay, so that's what you need to start working in the group. And what you also need for this, so this is the online version of Mendeley, mendeley.com, as you can see. What's very important before you do this, that you also install the Mendeley desktop, and this is the Mendeley desktop, and it's very easy to use setting. So here on the left are my groups, and by hitting sync, I can actually see, I can actually wait, and then the group that I just created, you can see, has now come on. But what I actually want to do, I want to actually create a pulmonary fibrosis search, and I want to do a systematic review on that. So that's actually what I'm going to do. So I open this group, and as you can see, it's empty. So my next step is to go to Embase, of course, and I'm going to search for this term. And of course, as Siobhan has showed you, I will also do that, of course. I will do this in PICO. Actually, I should have done this before, so I'll get rid of it. So I'll show you how it's done. And I will go to the population, as also shown, and then I will type in okay, here we go. And what I then can do, I can add all the 27 synonyms, so I don't know that I have done a complete search. Of course, normally I would spend a bit more time in going through that and see what I need and what I don't need. And then I will only do clinical trials, and I also do the synonyms, and then I've got 2,530 results, which is a lot. I recognize that, but that's that's okay. So what I'll do is actually, I need to be here actually, and I will select all the results in my results list, and then I will export them to this format Mendeley. Right? So as you can see, it's quite a lot of records, but that's fine. So Siobhan and I actually decided that we would sing a song, but Embase is so quick that we don't have to do that. So I'll download it, and it's here, as you can see. And the next step is for me to, very simple, I have this record with all the abstracts, all the records from my search, and I'll drag it into Mendeley and in the spot, and boom, there they are. As you can see, it's quite simple. And so what I have now is remember, this is a group. So this folder is something that I can share with anyone. Let's say I shared it with Siobhan, and then both Siobhan and I are going to go through each and every abstract. And as you can see, there's on the left you have the list of all the abstracts, and on the right-hand side is all the information from the record that I use to decide whether I'm going to push it through the next phase, which is actually downloading the full text and go through the article. But first, I need to collaboratively with Siobhan, let's say, decide whether this is in or out. And the way to do this, so this is one way of doing it, is basically I tag this, and I say that I'm going to say that I agree that this should be in our test, in our review. And let's say that Siobhan agrees with me, so she also puts something in. She will also see that I've done this, and then the next step is, and then you basically go through all these, and it could also be, of course, that she doesn't agree with me, and then we go to the next, etc. So that's the way to do this collaboratively. And what you can then do is is basically, so the next step is, let's say you've done all 2,530, it's quite a bit, probably you would narrow it down a little bit more before you do that. So you search here, and you search the ones that are in, and also one in. So once you've done that, basically there's two, and what you can do, you can select them all, and what you can then do is mark them as favorites. And basically what you then have, if you do this for the whole list, you can see which ones actually Siobhan and I agreed on that will be in the test, right? We can also do this for the ones that we agreed on that they will be out of the test, so they can be deleted immediately. And then the rest are the things that we'll have to have a meeting on and decide whether they're in or out. And then eventually you have a list of articles. So once you've done that, every article on the list can be found. And of course, there is the link to the article itself, wherever this may be. And I can download it and also easily add it to my Mendeley folder and go through the next phase of the systematic review. Yeah, so that's, I think, what I wanted to show. So as you can see, collaboratively, I did all the searching. That's also a strategy that we could, of course, do collaboratively in Embase, excuse me, using the PICO form. Created a list, in this case 2,530 abstracts, very quickly added them to Mendeley, started going through them by using the tags, and eventually coming up with a list of all the articles that we want to have for the next phase of our review, and then click on each for the link to the full text, and you can go to the next phase of your research. That's all I have for you. Thank you very much. I hope this is interesting, and I hope you have a look at Mendeley and, of course, especially Embase to see how those tools work in unison for creation of a systematic review. Thank you very much.
Thank you, Max, for showing and demonstrating really interesting process of how to exporting the records and then put it into Mendeley and how to manage it. I already received some questions from audience. You can see that people are very interested in this whole process and the workflow, how it does work. First of all, is that what can the reviewers add some additional notes to the reference in your Mendeley folder? So we see that you tag Xuan in, Max out. Are there any other place we can add more information or notes?
Yeah, that's a good question. So yes, there are. So you can share, you can put notes here, and they will be shared with the other reviewers as well. Yeah, that's a good question.
Okay, so we can use the note function. And the second is that, of course, we are demonstrating it, so we only import 25 citations. Suppose we want to actually import all those 2,500 records we found from this search results. Is it possible to do with Mendeley?
Yeah. You can. Yeah, sorry, I did. Yeah, it's yes, you can do all of them. Yeah.
Okay. And do you have a kind of a number in mind? What's the maximum import records we can have in the Mendeley?
To be honest, I don't. I think no. I have to owe you that one. I'm not sure how many there are, but it's thousands. Yeah.
Okay. I think it's important for some of the reviewers. They might start with of references first. Yeah. But we come back to the questions later, of course. Does Mendeley work with other databases rather than in addition to Embase?
Yes, of course. With all kinds of databases, our own Scopus, of course. But I think for this audience, PubMed is the most relevant one. If you do this from PubMed, it's also possible to have a huge number of downloads. You must make sure to use the Medline file format. So if you export, you click all the documents and then send to, and then it's the Medline file. So you send to file and then the Medline record type. So and then you follow the same procedure. It's a download in your Chrome box, and you drag the Chrome you drag the download to your folder. Yeah. So that works as well.
Very easy. Yeah, very easy.
Download and drag. Yeah. Although of course all those records will also be in Embase, and what then happens is that Mendeley automatically dedupes if you have overlap between the two downloads. Yeah.
I see. Okay. The audience is also very interested in the search that you have used in the Mendeley. So what you searched is max in and Xuan in, and using just simply and Boolean operator in the search function, in the search line, we retrieve the both results. So can you maybe just show us again what you have done?
Okay. Let's see. So I did max in. Yep. Right. So then I have all the maxes in, right? And one in, right? And then I've got two, right? And so these are two that basically that we both have decided, as you can see, the tags that we both decided on to have them in. Yeah. Okay. So it's with double brackets and the AND function. Yeah.
Yes. I think that's also very useful if you have more reviewers, and then we can also add more people.
Yeah, you can add as many as you like, of course. So up to 25 in the free version. I think usually up to 5 is what you normally do, right, with a systematic review. But so the thing is, where you all agree, right, Max in, Xuan in, John in, Mary in, etc., right, those are in. You can mark those as favorites, and then all the ones out, they can go. And what's left then, of course, is the ones that you need to discuss, where you disagree on whether it's in or out. And so that would be the process. Yeah.
Okay. So what is going to happen if all of us disagree, or all of us agree that this is not relevant for for the review? So what can we do with this record?
Yeah, you can mark them, but you can also just, you can also look for Max out and Xuan out and John out and Mary out, and you can delete them from your folder, and they're out of your way. If you really all agree, then that's fine, right? You don't need them, so then they will be gone. Yeah.
Okay. Yeah. Thanks, Max. I think those are really interesting questions for the Mendeley. And then I know for the audience, if you are interested in knowing more about this subject, and keep in mind that at this moment, Mendeley doesn't have the corporate offering. The main objective we are actually supporting is the academic research and also the evidence-based medicine that is in the research field. And if you would like to know more about that, we will provide you the contact information later in this links function, so you will be able to get in touch with some of the Elsevier consultants. And for the people who are from the corporate corporate customers, I would also like to recommend you to contact us directly. Then we can maybe offer you more corporate customized offerings. So this is for the Mendeley part. And I have two more questions from the audience about Embase. First, people asked how many records can be exported in Embase. So we've seen Max demonstrate that we can actually do 25, but we can also export more than that, of course. With the recent release, now Embase can actually export up to 60,000 records with 10,000 records per patch. That means you have to, every time the maximum export is 10,000, but you can actually in totally export 60,000 different records. And secondly is that we demonstrate using the RIS or export the RIS format in Embase. People also asked what are the other export formats available in Embase. So now we have the RIS, which is just demonstrated by Max for Mendeley, and we also have the reference work and CSV format, plain text. This year we add 3 new formats. Those are the XML format, Word format, and also the Excel formats. So those are different options for you to use for exporting and for you to integrating with your next steps. With that, I think we are almost reaching the end of this whole presentation. If you are interested in Embase or Mendeley, you can get in touch with us through the link we provide you. And if you want to watch the whole webinar and listen to it back, and this will be available after this live broadcast within the same link. And we will also upload the presentation slides for you to download and review. And with that, it concludes today's webinar. Thanks for listening to the webinar through the whole session, and thank you, Max, for demonstrating the really interesting workflow connecting Embase and Medline. And we hope to see you next month for the Embase webinar. Thank you very much, everyone, and enjoy the rest of your day.
Thank you all. Thank you very much, Sean. Thank you.
Thank you, Max.